Welcome to Legends of Data and AI. Each episode includes inspiring and actionable data and artificial intelligence insights from global leaders across industries. Your host, Dr. Usama Fayyad, was the first Chief Data Officer at Yahoo and is Chairman of Open Insights and Executive Director of the Institute for Experiential AI at Northeastern University.
Welcome, everyone. This is Usama Fayyad, and doing another episode of Legends of Data and AI. My guest today is Ricardo Baeza-Yates, who is very well known in the world of information retrieval, as he wrote the original book, Modern Information Retrieval, and then did a second edition on it. Between the first and the second edition, we had the chance of working together as we were building Yahoo Research, and he became the VP of Research, building out our presence in South America, Latin America, and Europe. And then later moved to Sunnyvale. He was with Yahoo for 10 years, then worked on some vertical search startup, and of course moved on to become professor of the practice at Northeastern University, and we're now working together again as he is the director of research at the Institute for Experiential AI at Northeastern University. Ricardo, welcome. I'll start with my first question. Your journey started in information retrieval and moved in a big way to the world of web search and search technology in general. Can we start with a question on what is the difference between these two general areas, IR and web search?
Yeah, thank you for the invitation, Osama. It's a pleasure to be here. And before answering the question, let me tell you a nice story, because really I didn't start information retrieval. I started in algorithms and in working in the Oxford English Dictionary project, which was the largest file on Earth at that time, 560 megabytes. That's like, looks like a joke today. And didn't fit in one single CD at that time. So there were like 4 CDs. So I did algorithms to search in the dictionary. And that was in '89 when I finished. So it was exactly the point where the web was starting. So it was naturally to extend that work on algorithms on information retrieval. So a few years later, I started information retrieval and doing web search. I think the main difference between information retrieval and web search is that the web adds some new things to the problem. So the first is a dynamic database. So it's not something static that was normally information retrieval like the dictionary. You need to deal with the data that is changing very rapidly, and also added the links, something that usually you don't have in traditional information retrieval, more like a hypertext idea. And that, for example, was the birth of PageRank. So I think these two things are the main ones. And the third one that came later is the signal coming from the user, coming from billions of people searching. So the clicks are the main feature today used by deep learning algorithms to do ranking.
Yeah, and I would say for sure, people have used relevance ranking and kind of the human in that loop in the search world, much more in the traditional information retrieval world. We have come a long way on leveraging statistical search. In your opinion, what is missing in today's state of the art on how we should retrieve and utilize information from large bodies of mostly unstructured text?
Yeah, I think what is missing is to add what we already know. So for example, in some sense, when you are using these large language models, you are rediscovering grammar, and you're discovering many things that we already know from language. And also we know that some languages are more difficult than others. For example, it's not using phonetics, really. So it's basically, I guess, rediscovering phonetics. So what I think we need to do is to add more semantics to it. So adding basically traditional AI, more like, for example, logic and different types of logic, different types of handling knowledge to this model. So we need to have more hybrid models that take the best of both worlds.
That's a great point on the fact that we try to reinvent much that is already known, and somehow we haven't yet figured out how to leverage it. For statistical search to work, much pre-processing, quote unquote, needs to take place. like stemming, synonyms, phrase modeling, specialized expressions, etc. You know, clearly English has received much attention in this area. Some other languages are kind of close followers, but the drop-off in coverage of languages is rapid and with a very long tail of languages that don't get as much attention. What are people to do in regards of these languages?
That's a great question. All this preprocessing you mentioned is language dependent. So it's not easy to basically extend to other languages. In some, for example, languages, the stemming hurts more than in others, and so on. And less than 5% of the languages in the world alive, that are almost 7,000, have a Wikipedia, for example. I think it's about less than 300, so not even 5%. And this is really, really bad. Many of these languages are already endangered by the United Nations category. So basically, there are languages that are basically used by less than 1 million people, and maybe they will disappear during this century. So one thing would be like to use, for example, transfer learning techniques to be able to basically do everything we have done in English and the top, say, 10 languages. For example, only in India you have 22 official languages, and go to try to improve search on those things. Imagine if you can do voice search for people that don't even know how to write a language, right? I mean, there are many places in the world where not all people know how to read and write.
And I honestly have been amazed over the decades of how little progress has been made on transfer learning in the work on machine learning, etc., which is as you point out, could be a very promising area to look and think. Going back to statistical search and modeling language, or the lack of kind of leveraging what we know about languages, as you mentioned before, we've seen the emergence of large language models offered by Google and others, like BERT and all the models named after the Muppets. Have these models been helpful, and what are the big issues with them?
I think these models have really been helpful. I mean, like you can find amazing examples of how from just finding patterns, you get, it looks like the model understood the semantics of the text and gives something reasonable. And that works perfectly. But the problem is not the accuracy of the models. And I think that's one problem of machine learning world, is that even if you have 99% accuracy, the problem is what happens with the other 1%? What happens with the errors? What is the impact of errors? They harm people. And for example, what happened in Google with the Parrot paper, and we will not enter there, but basically there are issues like gender bias, religious bias. There was a problem paper on how completions on Muslims things were violent. There are other issues on, for example, if you are using a lot of resources, like millions of dollars and a lot of like CO2 goes to the air, basically to maintain the past. And maintain the past means keeping that gender bias, keeping that race bias that you have in text. So sometimes it's not enough to reproduce the past. We need to improve the future. We need to basically do other things.
Yeah, and I mean, you make a great point. Very few people pay attention to the expense it takes to kind of run and update one of these models. And as you said, a lot of that energy is going into reinventing the wheel of things that are known, rediscovering grammar, as well as, unfortunately, re-encoding the past biases. This leads kind of into a more recent interest, a recent research interest of yours in ethical AI and especially biases in data. In your experience, what are the biggest pitfalls caused by the way AI and search algorithms use data? What can we do to detect or minimize the harm of these pitfalls?
Yeah, the first thing I would say here before answering the question is that the bias is not only on the data. So even some Turing awards say that. And for example, you have biases. You have biases that come from the models itself. And I have very nice examples in my seminars on ethics and AI about how the models find some optimization that leads to bias, like to a certain group of people. Also, sometimes the bias in the data is reinforced by the optimization. like for example, Claimer et al. Show with the bears in New York. And also the most dangerous bias is the feedback loop between the user and the system. Basically, the system is giving all the options to the user, and the user only can choose, say, 1 of 4 recommendations. Now you are going into like in a very narrow universe that you are creating, and then you have things like popularity bias, ranking bias, exposure bias, a lot of bias that I have exposed in my work on bias on the web. So to avoid that, we need to, for example, measure bias in data. We need to be more add common sense in models. So we think about what rules we should have. For example, if you have the example of the Italian delivery company, for example, have a rule saying I need to give the same amount of work more or less to all workers. Otherwise, we enter in a problem. So in that sense, you need to be like a communist. Give the same amount of work to everyone, because then you are fair with everyone. And then in the feedback loop, you need to be aware of all the biases that you create, and that means do more exploration. And companies don't like to do exploration because that's in some sense losing money right away, because you are not giving something that the person will click. But I believe that in the long run, you will earn more money, because then you will know your world better. So the only way to know your world better, say your market, is to do more exploration.
You may want to clarify for our listeners the issue with the Italian meal delivery problem.
Sure. So in this case, a group of workers felt that they were discriminated, and they sued the company, and was not clear reason why they were discriminated. So not all of them were immigrants, not all of them were women, not all of them were like one ethnic group, and so on. So at the end, the expert that analyzed the code found that naturally the system gave more work to the people that could deliver at dinner time, because that's the highest demand time. But then that meant that all the people that couldn't deliver dinner time were discriminated and gave to them less work. And the judge found that was indirect discrimination, because the system was not checking why that people didn't do that. For example, they could have children, they could have dependents to feed, or even they didn't want to work at night, which is a valid reason to not work at night. So they were fine, and basically much before the end of the case, the algorithm was changed to give this rule. For example, okay, let's give more or less the same amount of work to everyone, so we do a fair treatment of workers.
Yeah, and your point on kind of not most bias doesn't necessarily come from data. I mean, it's a good point, because I think the way bias creeps in is the fact that data, by definition, is a projection. It's a recording of, it's a partial recording of the world, and a biased, in a way, recording of the world where, you know, what did you sample, what did you measure, how did you measure it, on what scale, which leads to a very interesting.
So just to point out, so most bias, I think, comes from data, because we use so much data that it comes from there. Yeah. But I think we need to see what is the impact of each one. And for example, maybe cognitive biases on the feedback loop is much more impactful. That's why we have fake news.
Yep. So actually, this leads to a related question. You know, much information recorded is dependent on and encoded in a context. Do you believe our technology today in AI makes use of context? Are there glaringly missing ways of leveraging context?
I think partly we are rediscovering context. So the same that we are rediscovering semantics, which we call it pseudo-semantics and pseudo-context. Because sometimes for example, the famous example of wolves and dogs, that basically for huskies was not working. And then they realized that basically wolves were anything like a dog that has a snow behind. So that was the wrong context. Yeah, it's true, but doesn't work all the time. This is the problem. The most dominant patterns really don't imply the right semantics or the right common sense. So the question is how. So I think for me, context is part of the semantics problem. So we know a lot of things in advance. Sometimes we just look at each other and we know what we're thinking. So a lot of things is context. So again, I will say we need to add context in a semantic way. So like, okay, these are things that we already know about the system. These are things I already know about the person. And this means to use more knowledge graphs. So knowledge graph is a great tool, but still we are not using in the way that, say, a 1950 AI person will think about it.
Yeah. No, I mean, I agree with you. There is so much in context, and a lot of these issues.
And causality, and causality will be maybe number one in context, and there we have all the work of Judea Pearl pushing causality.
Yeah, and kind of figuring out the issues, which can be very, very subtle yet extremely important. So in that context, pun intended, if you're an executive in a company thinking about leveraging data and AI to help your business gain competitive advantage, what should you be thinking about?
Yeah, that's a great question. And we didn't talk about noise, which is another human thing that's important. So it's funny because I'm thinking I will publish very soon a Forbes Technology Forum article about the 10 key questions that every company should ask before using AI. So if you don't mind, I will just give the question, and then people can find the answers in the web. So for example, the first question is about competence. Do you have the right people to answer the problem? Because sometimes computer scientists are answering things that we shouldn't answer because we're not the experts. The second thing is also again about competence is, are you the one that should answer that question? So do you have the right to do it? And sometimes the answer is also no. For example, are you based in a scientific fact? And here we didn't talk about phrenology, but for example, if you're trying to, for example, predict some personality trait from video, is that something scientifically proven, or is just basically spurious correlations? Then you have many technical questions that are important on the ethical front. So for example, is your solution proportional to the problem? So are you using deep learning when you can use just a decision tree and use less money? Second, all the legal regulations, you always have to think about that. And then we go to the bias problem. Have you checked with bias? Have you checked with a bias created by the objective function of the system, of your model, the feedback loop that we already talked about? Then number 7 is something more subtle that also I like. So sometimes people has this, I don't know, obsession to fit people in categories like race, which is a social construct, or even, for example, now in the EU regulation, we have high risk, low risk, forbidden. I already see 2 problems in the boundaries. How we distinguish low risk to high risk? Risk is a continuous function. so that will create problems. And then you have thresholds in models. While you're using 0.5, people don't change the default, and so on. The last 3 questions are about society. For example, do you have explainability or interpretability of your system? So do you have humans in the loop? Very important. Then are your users fully aware of the impact of your system on their lives? Really? I mean, most users don't understand what they're using. And finally, the direct or indirect impact of your product or service. Are you really honest with yourself? Because then I would use a question I heard from Tina Eliasi-Rad. Would you use your system? I think this is a great question. So if you are not using it, there's some reason about it.
Yeah, I mean, listening to you, Ricardo, and if I'm putting my business executive hat on, what you just said confuses me more than helps me. Maybe the last question, the one by Tina on, would you use the system on yourself, is perhaps, one of the clarifying ones. But if you were to kind of couch it, and this will be the final question here, couch it in terms of like simplify the advice. Yes, there are 10 questions. Yes, as a business executive, you can go read them and try to understand all the topics, and maybe you don't understand half of those, and that's okay. But let's simplify that. Like, what is the final advice you would give when, as a business executive, kind of leads their business into a foray into this area of AI and data?
So I would say be aware of your biases. So the issue starts with yourself. And second, be aware of all the issues that the technology you're using may have. I think awareness solves 90% of all the problems we have.
Yeah, and I would actually encourage folks out there to think really hard about reaching out for help by experts like yourselves and others who kind of think about these issues. You know, we have at the University at Northeastern as a whole Institute for Ethics that's in the philosophy department that actually has a large collection of people thinking precisely about these issues. So reach out for help. It is available, and I think more than any other time in history, academics are very, very interested in helping on these topics because we're all trying to figure out this very thorny and tricky area, and we all want the best. We want the success of the technology as well as practicing it correctly. So with that, one last thought, Ricardo, maybe?
Yes, no, just saying that if you need help in the Institute of Experiential AI, we are soon starting many services like risk assessments, auditing algorithms, and very important, a board of ethics on demand. So if you have an issue, we will have top experts that will tell you what to do in private, what is the best recommendation for your problem.
Thank you, Ricardo. This is great. I mean, the topics are big. We're trying to keep the podcast short, unfortunately, and I would encourage listeners to reach out and ask more questions, and kind of don't hesitate to open up these discussions. It's a very rich and thorny and interesting and relevant area. So thank you for being here today.
Thank you.
Okay, and I encourage you all to tune in to the next episode and listen as we tackle more topics in Legends of Data and AI. Goodbye.
Thanks for listening to Legends of Data and AI. We hope you enjoyed our deep dive into the world of data and AI. If you're keen to learn more about making data and AI work in the real world and in any organization, join us next episode and subscribe to the podcast. As always, you can head over to open-insights.com to sign up for our email list, learn more about the work we do, and have access to data resources. See you on the next podcast.